Hello and welcome to Advent of Code Day 8. About a minute left here for the next problem to become available. Yesterday we were pretty lucky, pretty strategic in the way that we were able to get the answer to the first part of the question so quickly. Got a few points as a result. Hope to get some more points tonight, but that's going to depend on the problem and our approach and whether we make any mistakes. So a lot of factors in the balance here. We've got this Eclipse environment, which I haven't checked recently, but looks like it's still healthy. And yeah, seems like won't be too long now. What kind of problem are we looking for? How about a search problem? I think that Clojure is pretty good at those, and will allow me to hopefully find some good heuristics and attack the problem that way. 5 seconds, and here we go. All right, signal directly CPU. Okay, each instruction, the register to modify. Okay, this seems pretty interesting. Let's take a look at our input. What's the largest value in any register? Okay, so we have to run. So we have to run a computer program. I needed to call this input 4 here. So I'm gonna do this. Just like this, maybe. All right, so this is looking pretty good. Can I get the frequencies? I just want to see if every one of these lines has the same number of words in it. The answer is yes. So our parse function becomes a lot easier this way. So, all right. So what are the things here? So register to modify, mod the whether to increase or decrease. So instruction. What else? The amount by which to change it. Okay, amount. And then it's just always going to be if, and then another register which I'll call comp reg maybe, and then the compare operation, and then comp val, something like this. Okay, so you might also encounter less than or equal to or not equal to. Okay, so maybe if we change this to something like, if this is the instruction and then we have some kind of like state here. So let's see, register, all registers start at 0. Okay, so we might call this something like registers, and it seems like there's no jumps, so we should probably be able to use a reduce here. So let's see, in order to change this, we want to like update registers with some function from the current value of the registers at the one that we want to modify. And then the instructions, I think we have increase or decrease, the amount by which, okay. So then the modification function is going to have an if in there, and then within this if, so this is like going to be the condition state, and then we're going to say that if the comp, let's see, if the instruction is inc, then we're talking about plus. Otherwise, we're talking about minus. Yeah, we basically say that we're going to take this thing, we're going to start with the current value, and then we're going to modify it by the amount here. And that's on this side, and then otherwise we're going to leave this to be the same. Okay, so now we've done mod, inst, amount. Now we need the comparison stuff. So the things are greater than, less than, or not equal. Doesn't have the bandwidth to tell you what all the registers are named. Okay, so I think, I wonder if we could just use read string on this. I don't think this works. Oh, maybe it does. Function. Okay, no, that's reading it as a string. Okay, so then we're going to say basically we are going to do a case on the comp thing. It's going to be one of a few different strings. So like that, greater than or equal to is greater than or equal to, less than or equal to is less than or equal to, and not equal to is not equal to. So here's our operation, and then what we're going to apply that to is, so let's see. So we start with, we got to get in the registers the comp reg default to 0, and then just compare it to comp val. All right, so that should be our comparison here. And if our inputs is like this, I think the last thing that we just need to make sure of is that we do something like, if this value isn't set, then we make sure we default to 0. So let's see. What does Clojure? Oh, right, Clojure calls it not equal. Okay. All right. So then, given this here, reduce this function starting with an empty map. Oh, reduce parse starting with an empty map. I'm just going to take one of these here, and it's saying at the end of this SD is nil. So quickly checking here if k is not equal to 0. All right, that seems kind of okay, except I think I might just be a little bit happier if we say either the current value or 0. And registers, I'm going to actually be a little bit more cautious here and make sure that if this value is nil, then we turn it into. All right, so then the question is largest value in any register. So we're going to get rid of the take, and then we're going to take this thing, and we're going to apply max to the vals of this. No matching clause equals. Okay, yep. Okay, equals. No matching clause equals. Oh, I see. It's like this. Right. 3089. Answer, rank 85. All right, what's the next part? Highest value held in any register during this process. All right, so our reduce becomes a reductions, and then let's see, we want to map vals to this, and then this is going to give, and then actually we can just map cat vals and then apply max to that. Okay. All right, rank 71. There we go. Quick day, and we got some points. Let's talk about the problem. So here we have a CPU simulator problem, and what makes this a little bit easier than last time is that we don't need to store the program counter, because we know that each of the commands is going to be executed exactly once in order. So each of the statements in this case consists of 7 words, where it's basically saying this value is going to be modified by this function if this predicate is true. So because we're in Clojure, we can take advantage of treating functions like like values, and we took advantage of that in a couple different places. So yeah, besides that, just sort of like being aware of all the cases. Fairly straightforward implementation, I think. Let's just talk about the data structures here. So I'm using this real simple parse parse function that I wrote. That's just if something is new line separated, then it turns it into lists of or a vector of vectors of words. And yeah, so then this parse function, which should probably more properly be called like step or execute or something like that, knows that it's going to be receiving these 7 words here, and maybe I could have been a little bit faster if I just like called these like A, B, C, D, E, F or something like that, but maybe I would have made a mistake as a result. And so the way that I implemented this is I just represented registers as a map of strings to the values in the registers. And then I said that in order to execute this function, you're going to take that map, you're going to look up this key, and then you're going to apply this function to it. The other way to do something like this would be to take this test, basically to extract this test out here, and then instead of calling update, you could just like return the registers unchanged. That would also work. So yeah, so our test here is just basically, so what this S expression that I'm highlighting right now does is looks at what value is held in this variable here, and compares it to a bunch of these strings, and then returns a function depending on what that value is. And then so this S expression returns a function, and then since it's in the head position of another list here, when that gets evaluated, it basically applies this function to the arguments, which are, look up the value here, defaults to 0, and then here's the comparison. This problem would be harder if like these values could also be registers, but that it would still be pretty easy. And then there are only two kinds of instructions, increment and decrement, and those always take in a similar way. They always take a fixed value rather than like a register value. So yeah, same sort of pattern here, which is I don't know whether I want plus or minus, so I'm just going to use an if statement, and it's going to return plus or minus, and then yeah, I'll basically just take the current value here and modify it by that amount, and then yeah, and then this is the other part of the if statement, which is saying if the condition is not the case, then just either keep this the same. If it isn't, no, and set it to 0 otherwise. Yeah. So then that's then applying it to the computer is a straightforward application of reduce. So you start with an empty map. You work it for each of the lines in the input, and then I think I just could take I could just actually leave this like this. So take the vals, which are just all the values, and apply max to it. Gives us that answer. Then in part 2, it says highest value held at any point. So these are like the kinds of changes where closure is well suited, where basically instead of using reduce, you just change it to reductions. And what reductions does is instead of applying this function over and over again and returning the result at the end, this applies the function over and over again, but returns each intermediate value along the way. So then what I can do there is I can just, for each of those intermediate values, get all the register values out, use map cat, which is just apply concat to map, and then I'll have a list of every value that any register has ever had, and then I can just apply max to that. So quick day, good problem. I guess we can take a look at our Advent calendar. Here we go. All right, lighting up. Yeah, each day that we add gives us more complexity here, and takes longer to fill up the lights. So that's very nice looking at. And let's take a look at the leaderboard. So there probably is a way to find out how many points you have, but I'm not sure. I'm not sure where it is. I guess in any case, I could go through each individual day and add it up. But I bet I'm somewhere in between 100 and 200 right now. So definitely need to keep working at it. But if I keep having good problems and not making mistakes, then bet I'll be on here in no time. So that wraps it up. Hope to see you tomorrow, and thanks for watching.